Hi there. Thanks again for joining us. This is Space Nuts, where we talk astronomy, space science, and anything else that tends to pop up. We've talked about trains, we've talked about movies, we've talked about dogs and cats, and we might be talking about dogs today. In fact, we are. Strangely enough, nothing to do with the dog star either. We're also going to talk about something quite sweet. We did salty recently with the pink planet, but now we've found out there's a sugary centre in our galaxy. And what might happen when we land on the moon again? It's not good news, as it turns out. We'll talk about all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
He's back again for more. I don't know how he keeps it up because, I don't know, I worked in radio for 40 years and lost my voice many times, but Fred never loses his. It's Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. You probably jinxed us now.
I probably have.
Coughing in about half a mile.
One famous case I must tell you about. I worked for a rock station in Newcastle many years ago and I was doing a Saturday afternoon shift.
Yes.
And I must have had a virus of some kind that was sort of living underneath the radar. And during the progression of my 4-hour shift, was it 4 or 6? Might have been 6. My voice just deteriorated to the point where I actually couldn't talk, couldn't make a sound. And the program director rang and said, what's going on? I said, I lost my
yeah.
So he had to come in and take over from me. Was not happy. I mean, you can't help it.
No, you can't. That's right. You can't help it.
But that's one of my famous moments in radio. Or is it infamous? I don't know.
Infamous, that's right.
Yeah, amongst many. I should write a book.
Well, that's what you need to do. Yes, you should. You should write a book.
Because behind the scenes in radio, most people never know any of the stuff that happens, and some weird stuff happens.
Yes.
Some very weird stuff.
Yeah. Yep.
Now, Fred, how are you, by the way?
Oh, I'm fine, thank you. All good. Still sporting my my collision with the screen door the other night, but
it's looking a little better.
It's getting better.
The orbital rotation is starting to, look less radical.
Yeah, no, it's good.
Now,
I wear it with pride.
Yes, you do. At your age, though, it might take 10 years to fade. Now, before we get started, we've received a message from one of your friends and colleagues.
Yes, from Peter Verweyen, who's our link with the world of MOND, modified Newtonian dynamics. I actually saw him last week at the Astronomical Society of Australia's annual science meeting, and he said he'd drop me a line with an update, and I asked him if he'd mind if I read the update out on Space Nuts, and he said no, he wouldn't. But he did preface it by mentioning that they'd heard from the originator of MOND, modified Newtonian dynamics, Mordechai Milgrom, who seems to be calling it something else now, which was Aether Scalar Tensor Theory.
Oh, my goodness.
AEST. He basically keeps going with his research, although Peter suspects he's suggesting that the theory needs a complete rethink, which apparently Peter's been doing as well. Let me read what he says, though, because I think it's quite interesting for anybody who's been following this argument. MOND, of course, is an alternative theory of basically gravity, except it's not gravity, it's acceleration, which postulates that at very low accelerations, Newton's laws don't hold. The accelerations behave in a different way. And by very low, I mean the kind of accelerations that you get outside in terms of the movement of objects around a galaxy, things in the solar system are accelerating too rapidly for this to show up. That was the original premise, and it's of course an explanation for why galaxies don't fly apart as we think they should, because they're rotating too fast for what we can see to hold them together. And of course, that's why we postulate dark matter, the stuff that we think is invisible but does hold them together. So reading from Peter's email, He says, in a very vague sense, the universe might be like an onion, a bit like Shrek, if you know the movie reference. Imagine a bubble universe expanding from within its progenitor universe. In this case, the word universe can still be used because, like an onion, over time, as bubble universes explode into existence, yes, like a Big Bang, within the universe, we get layers. Penrose's book, Cycles of Time, explains the concept of a cyclic universe quite well, but he does some mathematical magic with how he handles scaling. Our idea is similar, but offers an alternative explanation as to why these bubbles explode in the first place. And as our idea develops, not a theory yet, we're noting similarities to other theories and models like K-essence, which I haven't heard of, and I bet you haven't either, Andrew.
No.
There's much to do to fully develop this into a theory that explains dark energy and dark matter, but one thing to note, looking for evidence of modified gravity around a black hole should be like looking for a needle in a needle stack. That's why the paper reporting mass discrepancies around supermassive black holes might put a dampener on quite a few modified gravity ideas. And we actually covered that. It was the evidence that there's stuff outside a black hole that is not normal matter. So thank you very much, Peter. Thanks for the update. And we'll continue to watch with interest what happens in the world of MOND.
Yes, indeed.
AEST.
Yes, as it's now called. Yes, lovely to hear from Peter as well. It's great that we get these little pieces of input from everyone and anyone.
Friends around the world.
Yes, right. Indeed. Let's get into our topics for today, Fred. And our first one sort of follows on from its opposing platform, which was our salty pink planet, which we spoke about a few episodes back. This is at the opposite end of the scale. We're going from salty to very sweet. Because it looks like our galaxy has a sugary centre.
Yes.
Now, what's interesting to me, Fred, is that sugar in the universe is not uncommon.
It's not. That's right. We've found it apparently in asteroids, actually.
And wait for it. It's why the universe is expanding at an accelerating rate.
Well, that could be one explanation. That's right, yes. And it's certainly the waistline that's expanding. So yes, it's a sugar. Sugar comes in different varieties. It's basically a chemical defined by the number of carbon atoms there are in it and how it combines with other atoms. So this particular one is called erythrulose. I'm not sure whether I'm pronouncing that correctly, but that's what it looks like. And its chemical formula is C4H8O4. So 4 atoms each of carbon and oxygen and 8 of hydrogen. So it comes under a classification known as ketos. I've heard of those. As you know, I'm not a chemist. So.
Isn't there a keto diet, or am I getting that mixed up with something else?
Could be, yeah. Could be. All sorts of things.
All sorts of diets these days.
Yes, but it's this time these molecules of sugar have been detected in interstellar space rather than in meteorites or asteroid samples or whatever. And those gas clouds where they've been detected are actually near the center of our galaxy. So it seems that it is probably something quite ubiquitous in the galaxy. It's a particular class of sugar, and I'm sure you've noted that it is actually the same sugar that you find in raspberries.
Yes.
Which
that's just...
It's bizarre, isn't it?
I don't know why we're surprised, because
no, that's right.
We are made up of the stuff of the universe, so it stands to reason.
That's correct. Yes, it does. And so basically, sugar is one of what you might call a prebiotic. Here, I'm losing my voice after our conversation before.
Yes.
What we might call a prebiotic molecule, one that is what we loosely term part of the building blocks of life. But these key ingredients of life basically can form deep in the universe in these what are called molecular clouds, giant molecular clouds, molecular nebulae, and you can get them before stars and planets form. That's the bottom line. So you don't need the planet formation process or the star formation process to synthesize sugar. It can happen in the cold of space.
That's amazing.
Yes, that's right. It's quite extraordinary. It's basically some research that's come from Spanish astronomers using Spanish telescopes, I think, radio telescopes. So a very interesting piece of research. And there's a sort of corollary which suggests that perhaps in the early universe, perhaps before the solar system formed, the residual gas cloud in which the solar system formed had sugar in it, which suggests perhaps the young Earth and the young solar system was bombarded by these sugar molecules as the formation took place. We don't know that, but that's a suggestion that's been made.
Yeah.
It's and there's a lot of it. This stuff. So it's sitting there in the galactic center, sweetening it very nicely.
Amazing and interesting. And I suppose it just adds one more flavour, boom, boom, to all of those things that are out there that we're learning are very, very common now, like water and salt and iron and all this other stuff. It's all just part of the conglomeration we call the universe. And it shouldn't be surprising that we've found sugar, which will make a lot of people happy. There's a lot of sugar addicts out there.
Yes, there's one sitting here.
I'm one of them as well, yes. Yeah. My wife is more of the salty variety.
Yes, that's right.
Yes. Mm. If you'd like to read all about it, there's a great article on the abc.net.au website about it, and I'm guessing there was a paper published, Fred, which I have not been able to find while we've been talking.
Yeah, it's in Nature Astronomy.
Of course it is.
Yes.
There you go.
Yeah.
This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Space Nuts.
Okay, Fred, let's go back to the moon. It's certainly getting a lot of attention at the moment with the Artemis missions and the Chinese presence on the moon at the moment. But there's a downside to all of this. We're putting people back on the moon in the not too distant future. But there's concern that this could mess a few things up, particularly the way we might destroy evidence of the origins of life on Earth.
Correct. And that's all tied up with kind of the reason why we're going to the moon in the first place. And that is certainly all in terms of the Artemis mission, the cratered regions of the moon's south pole in particular. The moon's south polar region is very heavily cratered. It's mountainous and is not a good place to land, but that's apparently where we're going to land. But because of the fact that some of these deep craters are never illuminated by the sun, they're in perpetual shadow, we know, at least we deeply suspect, or perhaps securely suspect, that's the way to put it, that they contain ice. And it's not just a guess. That comes from measurements that have been made, particularly by orbiting spacecraft over the last decade or two. So we think there is ice, and it's water ice, frozen water, down there in these deep craters. And that ice could be a bit of a treasure trove of the stuff that would have been entrapped coming from space, debris, dust probably, interplanetary dust. There's probably stuff that hit from asteroids, in the early history of the solar system and comets. And we think there might be this trove of ancient molecules, again, a bit like what we've just been talking about, trapped in the ice near the southern polar regions, or in the southern polar regions of the moon. And they're something that we'd really like to know about, because, if we could see some of these molecules which no longer exist on the Earth, because the Earth is a very dynamic geology and atmospheric physics. They've been recycled, they've turned into life, they've done all their thing. But if we could find these prebiotic molecules on the moon, that might be a way of seeing how they eventually combined and life emerged. That would be a sensational discovery to work out what triggers life. How does it start? We know that the prerequisites of life, molecular prerequisites, are sort of everywhere, but we don't know what the chemistry was like that caused life to come into being. So because the moon is almost like a time capsule in this regard, we would like to preserve this ice and keep it safe. So where it is now is fine, but the landing process of bringing a spacecraft down to the moon has an issue in relation to this ice, and it is done by this has been flagged because of computer modelling that's been carried out in the study that we're reporting, and that modelling suggests that the exhaust that comes from the rockets, the motors that will be used to touch down on the moon, and there isn't really another way of doing it. You can't, do a re-entry like the shuttle did, because there's no atmosphere to re-enter. But the exhaust is rich in methane, and that methane, apparently, the modelling shows that it could very quickly and permanently contaminate the ice. And basically get rid of any molecule evidence that we would have found in them otherwise. The modelling suggests that what are called the organic components, which are part of the exhaust of these lunar landers, would spread across the moon's surface very, very rapidly. And they basically studied how that would happen, including the radiation from the sun, including the solar wind. But there is a suggestion that that atmosphere, that methane, could very rapidly cover the whole of the lunar surface. The suggestion is possibly reaching from the moon's south pole to the north pole in less than a month or a couple of months. What we call two lunar days. Yes, very, very quickly.
Wow. That's a bit scary. I was going to suggest, we've spent all that money and time going to Mars looking for life, and there might be it might be next door, but maybe not if this keeps up. There's probably nothing much that can be done about it, Fred.
That's right. How do you essentially solve this problem? You can't glide down. It's got to be using rockets,
a space elevator.
Well, yes, the space elevator. There you go. But I think you've got
too costly.
You've got to put your rockets on the moon to start with to do that.
Well, that's the point.
You can't just dangle it down.
Yeah. It's a catch-22.
Yeah, there's a comment here from one of the scientists involved with this, who is actually a Portuguese. We have laws regulating contamination of Earth environments like Antarctica and national parks. I think the moon is an environment as valuable as those. So the suggestion is, maybe there should be laws protecting the moon. But as you said, what's the answer to that? Well, don't go there. That's really a very, very interesting piece of research. I'm sure this is going to promote or prompt a lot of conversation and perhaps debate about the ethics of this, and it'll be checked, I'm sure, very, very much, very, very carefully, because that's a really important result.
Yes, and look, they could introduce an international law saying, okay, moon's off limits, it's a national park, can't go there, but people will anyway. It's the same as we were talking about recently with nuclear weapons. We already think they're up in space, even though they're not allowed.
Yep, that's right.
So, here's another one. So that's not going to work either.
I think you're right. Knowing human nature, I think you're right. And the world we live in today as well.
Well, it's the old sign on the fence that says "Do not enter."
Yes.
Someone's going to ignore that.
Yes. Oh, I better go and have a look.
Yeah.
Yes.
But my frisbee, I've got to get my frisbee.
Yes.
Or
my dog, just for a segue there.
That's what we'll talk about next. But if you'd like to follow up on that story, it's on the space.com website, or you can read the study, which was published in the journal, the American Geophysical Union. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Space Nuts.
Now, Fred, we're going to the dogs, lost dogs specifically. Now, that's not uncommon, especially after a thunderstorm or a tornado. And you often see signs around town, have you seen my dog? And there's a pretty picture of the dog on the top of the A4 banner.
Yep.
But when you're in an area beyond, and there's technology around these days where you can put GPS or you can put trackers that require cell phone coverage and things like that on your dogs. But that's not always practical. But now there's a new way, and this is really quite fascinating about using GPS systems, satellite systems, to connect to your dog's collar.
Yes. So you're right. That's the perfect intro, because these devices do exist. Of course, there's many of us have got air tags that we use to keep tracks on our luggage and things of that sort. And we can certainly find one of those if it's hanging around your dog's neck. Actually, our dog doesn't have one, but most of my other stuff does, which doesn't walk away; it just gets left behind. But the issue arises that if you're away from a sort of standard suburban area and you really are exploring the wilderness, you're nowhere near a cell tower. And that means that these devices simply don't work. You can't locate your possession or your dog. And so this story is basically about how you can use, guess what, the Starlink technology to essentially find your dog even when it's not in a place covered by a cellular network. So that's rather an interesting thing, because it means that if you are in the middle of nowhere, no phone coverage, your dog gets lost, you can find it, but if you haven't got phone coverage, you're not going to know where it is. So you've got to have a satellite phone as well.
Exactly.
So if you've got that, then you can find your dog. Now, I am assuming that this relates to places where it's not illegal to take your dog into wilderness areas, as it is in much of Australia, because of the fact that we do have endangered species all through our country. And so dogs are the last thing that you want.
Yeah.
We have dog fences, in fact, don't we?
We do. We do have dog fences and rabbit fences and all sorts of things to stop the nasties getting through.
Yeah.
Geordie would not need this kind of technology, because when he barks in Sydney, I can hear him 300 miles away.
You can, yes. He just does one of his howls and everybody knows.
Yeah, the whole district knows. Yeah.
Yeah.
That's not an uncommon issue in residential areas, the dog barking problems. So this is a fairly new thing from what I've read, because it sort of came on the back of the Starlink technology. But it's also a fairly simple thing, I suppose. If you are out in the wilderness and there's no mobile coverage and your dog chases a bear or whatever, this could save its life.
That's correct. Yes, that's. I guess that's the good side of the story. So there've been, animal trackers for a while. Apparently, 11 million dogs are tracked or monitored by GPS in some form.
Is that true?
Throughout the world, yeah, that doesn't surprise me. There's a lot of dogs in the world.
Yeah,
but this is a step. A step further, this new connectivity, because it's a bit like D2M, which is direct to mobile from using satellites. If you've got direct to mobile, then you've basically got a satellite phone. And I think Starlink are working on bringing that out quite soon if they haven't done already. So it's that sort of technology. It's the direct to mobile or direct to cell technology that you can now adapt to dogs, apparently.
Well, no, that's a good thing because dogs do run away. They get excited and they wander off, or they meet another dog, and next thing you know, they're in Siberia.
Yes,
it's happened.
Yes.
This reminds me of something that was done many, many years ago up around the Warrumbungles. We used to live in Coonabarabran.
Yep.
And it was the Judas goat program. You remember that? Judas goats?
Yes, I do. I do remember that.
Goats are an invasive species and they cause a lot of damage in national parks in Australia. So what the National Park Service did was they would put a tracking collar, a GPS collar, on a goat, and they would release the goat into the national park, knowing that it would eventually find a herd of feral goats.
Yep.
And then they could go in and, let's just say, deal with them.
They do deal with them. They use helicopters as well.
Yes, they do.
Yes,
so the old Judas goat was using this kind of technology. But now it's more freely available for domestic purposes, I suppose, Fred.
That's right. For other invasive species like dogs and cats.
Absolutely, yeah.
But keep them out of the national parks.
Indeed. Really interesting story. That one is also on space.com, but there's every chance that if you're in the right part of the world, you might be using this technology already. Apparently 11 million dogs do. Gosh. I think that brings us to the end, Fred. That was quick.
It was quick. And that's kind of brought us up to date, I think, hasn't it? With life, the universe and everything.
Yes, indeed. Yes.
Yes.
Anyway, thank you very much. We will catch you on the next episode coming soon.
Sounds good. I'll look forward to it, Andrew. All the best.
Professor Fred Watson, astronomer at large, part of the team here at Space Nuts, and thanks to Hugh in the studio. Hugh couldn't be with us today, tends to wander off, and his wife's fitting a GPS collar to him as we speak. And don't forget to visit our website between episodes, spacenuts.io. And from me, Andrew Dunkley, thanks for your company. We'll be back with a new episode real soon. See you then. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.